Hello, and welcome to a little video about exponential growth and exponential decay. Let's start with the formulas. I'm going to write them down and of course I will define them. The exponential growth formula is f of x equals a times 1 plus r to the power of x. A is our starting amount. Just like A was our y-intercept when we were just looking at regular exponential functions without considering growth or decay. A is the starting amount, which is, again, the same thing as our y-intercept. Because it's exponential growth, I have a plus sign, and this r right here is the percent rate. Or the percent change, percent rate, that's silly. Percent change. Now, exponential decay is almost the same. Check it out. It's f of x equals a, the same a as before, times 1, but instead of plus, this time we have a minus since it's decay. And then r, the same r as before, to the power of x. Okay. What we're going to do in number 1 is identify whether these functions are growth or decay. We're doing this based on their parentheses. Letter A. Letter A has 1 plus inside the parenthesis. It's growth. Letter B has a minus. It's decay. Letter C has a number smaller than 1 inside of its parentheses. That's decay. Letter D has a number greater than 1 in its parentheses. Growth. Letter E has a minus. That's decay. And letter F has a fraction inside, but that fraction is greater than 1. So it's growth. For number 2, what we're going to do is just write exponential functions for these problems. We're not going to solve anything, but we're just going to write them. Okay. Letter A. A $250,000 home increases in value by 6% annually. First, let's remind ourselves annually means every year. Second, we need to make sure to take that 6% and turn it into a decimal. The way you do it is you do 6 divided by 100, which gives you 0.06. Or, if you like the trick, you take your number and you move a decimal place over twice. Alright, so f of x equals our starting amount, so 250,000 times 1 plus, because we're increasing, and then our rate, 0.06. A $5,000 refrigerator decreases its value by 3.2%. All right, we start with 5,000. We have 1 minus because we're decreasing this time. And our decimal, or our percent as a decimal, is 0.032. Now, I often have students going, hey, Gumin, 3.2 is a decimal. You're right. 3.2 has a decimal point in it. However, 3.2 still has a percent sign at the end. So even though the decimal exists in the percent, it's still not in proper decimal form. Letter C, we buy a new car for $25,000. Pretty nice, pretty standard. It decreases in value, 1 minus, by 15% a year, 0.15. A baseball card you bought for $5,000 increases in value 5% a year. F of x equals 5,000 times 1 plus 0.05. Letter E. A population of ants starts to increases by 50% every year. Let's write a function. F of x equals 30 times 1 plus 0.50. Alright, last one. We have a starting heart rate of 140 beats per minute, which decreases by 10% each minute. F of x equals 140 times 1 minus 0.10. All right, let's start applying. All right, so what can we apply it to? First, let's talk about population. That's one of the most popular, most common types of applications of exponents. First and foremost, we need to write an exponential model that represents a population of ants that starts at 50 and increases at a rate of 15% a month. F of x equals 50 times 1 plus 0.15 to the power of x. Letter A actually gives us a coordinate for our graph. It gives us the starting point, 0.50. Letter B and C are going to give us 2 more points. In letter B, what I'd like us to find out is what is the population after 5 months. The way we do this is we take 5 and we plug it into x. Okay, what you're going to do is you're going to put this part in your calculator, and the answer you get is going to be our y coordinate. So after 5 months, we have about 100 ants. I rounded down because we can't have point something of a living being. Next, let's find out the population after 10 months. Same idea, we're going to go ahead and plug this in with a 10 in place of x. You're going to put this whole part into your calculator. Let's see what we get. We get 10, 202. Let's graph it. Our point from A is 0.50. From B, it's 5, 100. And then 10, 202. That's a nice function of population growth. All right. Now this next one, not as accurate, because I wrote this a couple years ago. I really liked all these problems, so I didn't really change much about them. So a Tesla Model S does not cost $95,000 anymore. So let's imagine whatever amazing $95,000 car that we're planning to buy is decreasing in value about 16% a year. Let's write a function. F of x equals $95,000 and then 1 minus 0.16, right? Because we're decreasing. Okay, that gives us our very first point, 95,000. Okay, next, what we have to do is find out how much the car costs after 5 years by plugging 5 into our function. Now, I'm hoping that you are practicing this on your own as you watch this, but here's my answer. When I plugged in 5, after 5 years, my car, and I'm rounding a little bit, is worth $39,730. That's right. After 5 years, it's lost over half its value. What about 10 years? Let's see. F of 10. All right, so we're going to type in our calculator. Type, 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 type. I know it's so annoying to type these all the time, but I promise it's going to get easier and you'll have some muscle memory about it. After 10 years, our car is worth $16,615. Isn't that crazy? The car market is insane. Let's graph it. 0, 95,000. 5, 39,000. And 10, 16,000. Gorgeous. Okay, maybe not that gorgeous. I kind of missed that middle dot, but we did fine, Gumin. We did fine. All right, onwards we go. Ooh, another very popular thing. Of course, I made these problems. I'm excited about doing them. Silly me. I'm considering depositing, so putting in $500 into an account that pays 1.5 interest every year. Pretty standard. F of x equals 500, 1 plus 0.015. Just like before, we get our first point here, 0,500. Okay. Now, we're imagining that we have left this money in our account, we haven't touched it, for 15 years. We're just that rich that we don't care about 500 bucks. Or you know what? What if a relative made us an account and we just didn't know? Yeah, that sounds better. After 15 years, get ready to be shocked. You only have 625 bucks in there. Right? Crazy. But it's such a small percentage. Things do that. Alright, next. Let's see. 50 years. So this is why I think maybe a relative left us this money and totally forgot to tell us about it. Because who forgets about 500 bucks for 50 years? That's pretty crazy. After 50 years, our money doubles. We have $1,052. Let's graph it. 0, 500. 15, 625. And then 50 all the way here. 1,052. This is such a slow growth that it almost looks linear in this little bit. It's not. It's exponential. But it grows so slowly that it almost looks straight. Crazy. Okay. One more application about medicine. You take 1,000 milligrams of Tylenol. Every hour, the amount of Tylenol in your body decreases by 24%. This is very important for doctors and prescribers to know. If you ever took a look at the back of your medicine bottles, like Advil, Tylenol, ibuprofen, Excedrin, it will tell you, take this amount every so many hours. And that is because they used exponential models to see how long it takes for that medicine to dissipate in your body, right? So when would it be safe for you to take more of that medication? Like if you have a headache, you want to know how much you can take safely, and you don't want to take too much because you could give yourself poisoning, or if you go overboard, you could go bye-bye for forever. And I would not like that. Let's write a function. 1,000 times 1 minus 0.24 to the power of x. Now, Tylenol, I believe, actually, I guess it depends on the milligrams you take. It's either 4 to 6 hours or 6 to 8. So let's see. After 4 hours, how much is left if we started off with 1,000 milligrams? After 4 hours, whoa, you see that? What's my screen doing? After 4 hours, we have about a third of it left. Let me double check. I know it's 333. Yeah, 333.6 milligrams. Oh, we forgot to say this is our starting point. 0,000. So yeah, after 4 hours, it's about a third gone. So, how much is left after 12 hours? I think 12 is too long to wait between Tylenols. But let's see how much is left if we didn't take some more afterwards. Okay. So 12 hours after taking Tylenol, just once, just one dosage, we have about 37 milligrams left in our body. Which, I'm not a doctor, but I think that makes it safe to take some more. So we definitely need these exponential models to make sure people are taking their medication correctly. We don't want medical accidents to happen. That's terrifying. All right, let's begin. 0, 1,000, because that's how many we started with. 4, 333. It's right here-ish. 12, 37. That's there. So, as you can see, your body absorbs it pretty quickly. I'm assuming that this particular function might not have an asymptote. I don't know, because it's gotta reach 0. I honestly don't know. I'm gonna have to look into that. I'm curious. You probably won't, but I'm curious. There's gotta be some sort of, or maybe we just know because it's medicine, it just can't exist below 0. You can't have negative Tylenol in your body. That's weird. Anyways, last problem for our unit. A construction company bought a new bulldozer for $120,000. The value depreciates, means goes down, at a rate of 20% a year. Let's write a function. There it is. F of x equals 120,000 times 1 minus 0.2 to the power 0.20 to the power of x. Now this isn't going to get too messy, so let's color code it. Depreciates. Where's my depreciates? There it is. 20%. Oh yeah. Alright. In order to fill in this function, what I'm doing in my calculator is entering it over and over again with different x's. Alright. So I'm putting in my function with 0 as my exponent, 120,000. So year 0 is when we bought it. Year 1, I plug it in with a 1 in the exponent. After a whole year, it's $96,000. After 5 years, it's $39,321. After 10 years, it's $12,885. And again, I'm using this function here. After 12 years, it's worth $8,246. And after 25 years, following this model, it's only $453. Let's graph. This graph goes by 10,000s. So 10, 20, 30, 40, 50. That's 50. 60, 70, 80, 90, 100,000. Okay. I just needed to see where it is so I can graph properly. Year 0, we start with 120,000. Since I did pink there, let's do blue. After 1 year, we're at $96,000. So here. After 5 years, we're at $39,000. After 10 years, we're only at 12. At 12 years, we're at 8,000. And I don't even have a 25 there. Let's draw a line. Ooh. Let's attempt to draw a line, Gumin. Let's do this. We can do it. Yeah. Okay. Let's analyze some questions. The company wants to sell the bulldozer in time to make $30,000 off of it. So, when should they sell it by? Well, let's see. This here is 30,000. Let's see where it hits our graph. Boom, there it is. Whoa, I didn't know that would happen. Ooh. Well, it's before 6, it's after 5 years. If we sold it at 6 years, it would be below 30,000. So, by 5 years. By year 5. Let's do that. By year 5. Because after that, as you can see, once it cooperates with me, thank you. After year 5, you are risking going into year 6 and falling below $30,000. Right? What if we wanted to sell it for 50,000? Okay. Well, let's see. Here's 50. Stop it. Why are you not cooperating with me? We're almost done. Now you're doing this? This is rude, computer. Thank you. All right. 50,000. Oh, it's right there. So it does hit my graph between 3 and 4. I don't really want it going that much past 3 because it will fall below $50,000. So let's say by year 3. And what if we only wanted to get $10,000 out of it? Well, based on my table, it's definitely between year 10 and 12. Let's see how well I graphed this. All right. This is 10,000. Oh, yeah. Good job, me. It falls around year 11. So between 10 and 12. By year 11. Now here's a question that's not on the graph. When will the bulldozer be worth $0? Think about it. Think hard. The answer is never. In our economy, you can always sell something for something. Maybe your bulldozer breaks, but you can sell it for parts. You can take off the wheels. You can take off the controls. You can take off the shovel. So it's gonna be worth something. Gotta make some money out of it. All right, that's our that's the end of our unit. Exponential growth and decay to connect it to some real life. If you have any questions, please ask me or whoever else is helping you in math. Otherwise, have a wonderful rest of whatever day it is for you.